you very much for organizing this forum and providing me with the opportunity to presentation. Today, at the beginning of this session, I will talk about star scientists' contribution to regional innovation ecosystem. This is the result of collaborative study with myself and Kanetaka-san for the studying star scientists and innovation system. So I will start. First, star scientist is, in one sense, the scientist who is highly cited and who has special performance in academic activities. And prior studies by Zaka and Darby shows that there is a co-relationship between the localization of star scientists and startup companies. In their study in 1998, this is about biotech field, and also they continue the study, and also in their study in 2007, they also show that such co-relationship in biology, chemistry, and medicine, star scientists and firm entry in US regions. And also for nano-scale science and technology, star scientists and firm entry. And also they shows the worldwide co-relationship in bio, chem, med, and also nanoscale science. They also show that there is, in some regions, there is a virtuous cycle between star scientists and firms. Star scientists provide a good performance to firms, and firm also provide good performance of star scientists in academic attainment. And this is the so-called Stokes quadrants. Some scientists seek for fundamental understanding of science, and some others are not. And some scientists consider how to use the result, and others are not. And there is a Edison quadrant and Boas quadrant and a Pasteur quadrant. This is the quadrant for applied basic research, which seek for fundamental understanding of nature and also consider how to use it for society. Usually, consideration of use is counted by number of patent or relationship with company. And also, seeking for fundamental understanding is counted by a publication. Here, we focused on San Diego in the United States, its innovation ecosystem. According to the report by Porter and others, San Diego is supposed to be a highly competitive cluster, particularly centered on the ICT and pharmaceutical biotechnology industries. And it's accomplished via university industry government cooperation in this region. And this is the fastest growing economic areas, one of the fastest growing economic areas in the US. So we focus on San Diego, and here we used the list of highly cited researchers by Clarivate Analytics, and we found 66 star scientists who are highly cited in each academic field that is existing in San Diego area. And we collected data of publication and patents. Among the 66 star scientists, almost half of them are from University of California, San Diego, UC San Diego, and others, Scripps Research Institute, Craig Venter Institute, or Salk Institute. There are various high performance academic research institutes in San Diego. And also Qualcomm is a private company, of course. And we counted articles and patents, or article per year, a patent per year, a patent per article of each 66 star scientists in San Diego. And we picked up 12 very characteristic performance star scientists in San Diego, and we classified them into several groups. Some becomes the co-founder of companies, and others advisory of companies. Both are active in company, but co-founder is a very more close relationship with companies. And some applied for patent with the company in which they co-founded. They applied some patents with that company, and others are not applied for patent with that company. This group is the star scientists who are very hyperactive in article publication, but not so active, rather inactive in patent application. But this kind of star scientist seems to be Bohr type scientists. However, they are also co-founder of several companies. So we suppose these scientists are a kind of hybrid type star scientist, hybrid of Bohr and Pasteur. One of the three scientists is Dr. Eric Topol, and actually we interviewed him 2 years ago. Eric Topol was selected as one of the 12 rock star in science by a GQ journal, popular journal in 2009. And his research field is personalized medicine, combining genome and digital technologies. He was one of the 12 stars in San Diego investigated, and article hyperactive and patent inactive. His patent application is only 2 US patent application, in which his name is listed as inventor. However, he is highly related with companies, sometimes as co-founder. His CV is here. He got MD in University of Rochester in 1979, and after 1985, he was working for University of Michigan as tenure position, and he moved to Cleveland Clinic in 1991 and moved to Scripps Research Institute in 2007. During that, he is related with a lot of corporations and whose headquarters is in San Diego for these red-colored companies, and blue is in California, and black is not outside California. So he is related with the companies inside San Diego, a lot of companies, including Illumina, very key company in the San Diego innovation ecosystem, and a lot of companies in San Diego. So we assume that he is one of the key star scientists in the innovation ecosystem in San Diego. We will look at the publication, chronological publication data. He in University of Michigan period, and Cleveland Clinic period, and Scripps Research period. This is the number of articles, and we classified them into first author article, and last author article, and other article. So in the University of Michigan period is mainly first author period. And Cleveland Clinic period is last author period, in which he is a PI of research group. And in the Scripps Research Institute, he became some management position. So most of his publication is not first author and not last author, other position. And this is a largest citation for each publication year. Also, in the Brown Clinic period, he marked the highest citation in his research career. So here we have to consider how we can bring up star scientists. In other words, what percentage of promising young scientists become stars? We have constructed a short list similar to the method of candidate analytics, and also a long list of star scientists. 5 times number of people is included in the list, and we use it for our analysis. Here, I explain the method of extraction of promising young scientists. We used Web of Science, and we identified the researchers who affiliated with Japanese institutions and published highly cited papers as first author in year 2008. And also, we collected such researchers in San Diego County and its 3 neighboring counties, and we call it San Diego researchers. And we used Web of Science and selected the researchers whose first year of publication is 2000 and after. And we extracted 169 Japanese scientists and 103 San Diego scientists. It means that those scientists published their paper after 2000. And in the early stage of their research career in 2008, they published first author, highly cited paper as first author. So they are assumed to be a promising young scientist. And this is the result, whether they have become stars or not in San Diego. There are 32 people, that is 31% of the sample has become stars in short list or in the long list. This is the number. And this is the result in Japan. Only 8 people among 169, that is 5%, has become stars. That is smaller percentage of researchers have become stars in Japan than in San Diego. Yeah, we also divided them into the group serial highly cited paper publisher. They published the highly cited paper since even after 2009, and the other group who has not published highly cited paper again since 2009. The serial publisher is Group B, and others are Group A. And we made an analysis on a number of publication, highly cited paper, or ratio of highly cited paper. This is one of the figure. This is about transition of the ratio of highly cited paper after the first year of publication and the average of the samples. This is a comparison between San Diego researchers and Japanese researchers. There is a distinct difference in the ratio of highly cited paper in the early stage of their career, first to 7th years. So, and also, this is the comparison of San Diego and Japan for Group B serial highly cited paper producers. Relatively ratio is higher in San Diego. And also, we checked the ratio of co-authorship papers with other star scientists. And upper column is Japan, and the lower column is San Diego. Relatively, the researchers who have become stars marked the higher percentage of co-authorship with stars than others. And the percentage is higher in the 2009 and after period than 2008 and before period. And it is applicable to the researchers in both regions, Japan and San Diego. So, I summarize my talk. First, several studies showed that location of star scientists are correlated with that of startups. And in some regions, virtuous cycle of stars and firms is established. And in San Diego, regional innovation ecosystem is established in which a key player is star scientists. And as for the percentage of promising young scientists who have become stars, that of Japan is lower than that of San Diego. And it might reflect some difference between Japan and San Diego in the environment of research at the early stage of scientific career. That continues to the discussion topics. And that's the end of my presentation. Thank you very much.
Okay, thank you very much, Professor Sumikura. And I think since we have two related but slightly different topic, let's have a Q&A session for Professor Sumikura's part at this moment. So Ryan, could you facilitate any questions from the audience, please, for a few minutes?
Definitely. Let's say whether we have any questions on the floor.
Thank you very much for a really interesting presentation, because that global talent is effective in activating research environments. I was going to ask you whether any differences in the laboratory, if they were in a laboratory or research group structures, between those Japanese and San Diego scientists. Was there something which in the environment seemed to limit, given the talent had been there early?
Yeah, thank you very much. As long as we saw, one of the difference between Japan and San Diego or United States is the hiring system of university faculties. In Japan, higher percentage of people stay in the university or institutions in which they got their PhD. However, in the United States, usually they move to the other institutions. That is a kind of mandate. So that's the diversity of experience of institutions might be a very competitive environment, and also that might contribute to the good result of producing star scientists. And that's my assumption. Thank you.
Thank you. I think we have online participants. Professor Groening has a question. Yeah, we can let him to ask his questions himself. Yep.
Good morning. Thank you. Thank you for a very interesting presentation. I just it's just a piece of information or whatever, but I happened to discover Professor Topo that he has a very active Twitter account, so I can recommend that, where he sort of gives a lot of information about COVID and so on in these days. So maybe he has sort of redefined himself rather sort of like a public educator in the recent years. So it's just a comment.
Yeah, thank you very much. Yeah, we met actually Professor Topo, Dr. Topo, and he's very active professor. However, he is very sincere to science, scientific attainment, and also So he cannot respond to all of the requests from industry. However, he select which company to collaborate for enlarge his contribution to society by his technology. So that's the hybrid attitude of Boa and Pasteur. I think so. It's a very good example of sincere basic researcher contributing to society. Yeah, thank you very much.
And thank you very much for the question. I'm also the co-author of the paper. So, Eric Topol is exception in a way. So we are trying to expand, conducting more interviews for the scientists in San Diego as well to compare with situation of Japan. But thank you very much for your comments. Okay, any other comments from the conference room?
Sorry, there's another question, please.
Yeah, it's Mike Richards again. I just wonder if there's any correlation with the business environment as well, the ability to start up companies and the number of startups that might have been occurring in the different locations that the scientists were actively operating in.
Yeah, thank you very much. I agree. And not only the existence of star scientists, but also the environment for collecting a lot of investment, especially from venture capital, is also a very important factor for innovation ecosystem. I totally agree.
But can I just add one more thing? So according to Zucker and Darby's previous literature, and they say that there's a connection of like amount of venture capitalists has a positive impact on formation of startup. However, when we compare the size of the impact between the amount of venture capital funding and the existence of the star scientist, the existence of star scientists is much, much larger than venture capitalists. So according to their view, they conclude that talent is more important than ecosystem itself. And when we go back to the talk, yesterday's Professor Tomita's presentation, when he went to Tsuruoka, there was none of ecosystem, no venture capitalists at all. Then after all his effort, they created like 8 startups. So in that sense, probably talent might be more important. That's one view. But thank you very much for asking the question.
Thank you. I think it's a very interesting topic and star science. We have a final question here, just a quick one.
Okay.
I'll just be quick if I can. We're just interested in the definition of a star scientist. You've linked that to startup, but I'm just wondering, in Japan, is there a level of co-authorship with industry, established companies, large corporations, that you see a much larger uptake of co-publishing articles, etc., with established industry rather than just new companies?
Okay.
Thank you very much. Yeah, about the co-authorship paper between star scientists and company, we will look at the situation later. So now, future topic. But now we just look at the relationship between young scientists and other star scientists, and that shows some difference between those who become stars and those are not. So industry collaboration paper is a future topic. Thank you very much.
Can I just add? So we don't have the published article yet, but we have some preliminary analysis. And according to the Zucker and Darby's paper in 1980s, there was many collaboration between star scientists and big firms in Japan. And what's interesting was there was no formal contract between the university and firms because the university didn't have a legal entity at that time. But there were many collaborations. Then after that, we looked what's happening right now. And still it's a preliminary research, but what we found is that now startup scientists tend to work more with startups rather than big firms. That is a big change, what's happening in like 10 years right now. I hope this helps.
Thank you. Interesting.
Thank you. I see your.
Okay, so let's now, thank you very much. So now let's move to the second panelist, which is Professor Yoshioka. He will also talk about role of university, as well as he knows very well about the University of Tokyo ecosystem, which is one of the biggest startup ecosystem in Japan right now. So please begin, Yoshioka-san.
Thank you, Kanetaka, for my introduction. So I'm Toru Yoshioka Kobayashi from Hitotsubashi University. And today I'd like to talk about the innovation district issues, mainly about the great challenge for somewhat not reading innovation district, particularly the business environment for VCs and other professionals to support university-based startups. And then I will talk about some linkage between startup scientist argument with the innovation ecosystems. So let me first talk about the concept base. This is a very, commonly recognized concept of the university-based entrepreneurial ecosystem. I interpret as a positive feedback loops of resources. Maybe I'm focusing on the knowledge circulation, as well as some financial resource circulations. So for example, the university provide a knowledge and a spin-off. And then the university technology-based startups and the student-based startups emerged. Then the VCs and the professionals provide a knowledge or investment. And if startups succeed, then the VC will gain a capital return and the professional will gain a fee. So this is somewhat circulated between the new generation of the startups. And before entering my main topic, let me introduce the case in Tokyo. There is the Hongo Valley. It's a kind of an innovation district created around the University of Tokyo. The University of Tokyo now have about 300 startups. And near its main campus, many successful and prospective startups are headquarters. It's obviously kind of innovation district. 35 firms in the incubation facility and around 100 startups located near the campus. And this is mostly within 1 kilometer. So very dense area of startups. So that's why we named after the Silicon Valley, we say Hongo Valley. The Hongo is the location name of the campus. And in this Hongo area, we have 2 VCs, which is university-related VCs. And also we have several private VCs. So these companies received a great amount of research, the operation funding and any other investment from these VCs. For example, there are several prospective companies. The most major one is this company, Bionic M, who manufacture robotic artificial arms and legs. So they already raised $20 million by the mid of this year. And the other 2 companies are already exited. So Shaft, which is a human robotics manufacturer, they already acquired by Google for $500 million in 2013. And the other company is Pop-In, which is about the internet advertisement analytics service provider. They already acquired by Baidu, a Chinese internet service company, in 2015. So, and there are many other examples of successful startups in this area. And the snapshot of this Hongo Valley is like this. The university, particularly the University of Tokyo and other universities as well, they contribute to establish startups. The main contributors are students. Of course, originally the faculties contributed to establishment of startups, but recent successful startups are mainly student startups. Anyway, these startups already successfully IP listed. So university-related VCs already get the sufficient capital gain, so they can again invest to the new startups. And another prominent characteristics of this area is there are a number of alumni mentors. This alumni mentors means the former CEOs of startups and alumni from the University of Tokyo or other universities, including the Waseda or Keio. They mentored the newly founded startup CEOs, as well as they behave like an angel. So they invest the money. So, and another interesting aspect is entrepreneurship education opportunity. The University of Tokyo, for example, they provide an official program. But this program is very interesting. Originally established as a semi-official program, partly supported by the university, but it's some kind of a mixture of volunteer activities of several faculties. But anyway, now the alumni mentors, they contribute to this educational program because they lecture some issues and also they mentor their alumni CEOs. Then they enhance the further establishment of startup. And the third interesting aspect is the several startup-oriented lab create many startups. So particularly in the field of material science, robotics, and artificial intelligence field. And what is the advantage of the near campus co-location? This is our research. We interviewed 93 startup CEOs and other top executives. From these startups are mainly from the University of Tokyo. Our interview is conducted in 2019. That means before COVID-19. So interestingly, we found that the co-location increased the frequent communication with the mentors. So here is these two figures indicate that the blue color indicated this is the frequency of communication with the most helpful mentor. So for example, in the managerial issues, the near campus located startup CEOs communicate with mentor about the managerial issues 2.8 times per month. And this is the right side is a virtual mentoring opportunities, so 6.8. But anyway, the interesting finding is, of course, the face-to-face mentoring, the co-location near the campus is the most advantageous to get such communication. But at the same time, even in the virtual environment, they have more frequent communication with these mentors. And another interesting finding is the vast majority of startup CEOs names the limited university-related VC executives as the most helpful mentors. So the VC are great help to these university-based startups. Again, but let me dive into the innovation district issues, particularly from the science policy perspective. One of the challenges, honestly, as maybe Kanetaka already mentioned about that, the Tsuruoka, for example, they are great scientists, but Tsuruoka is not has not the ecosystem, and Kawasaki maybe as well. Other than Tokyo, we have many university, world level universities, cities. However, there are no established university-based startup ecosystem. Even though the government and the university have been made great effort at incubation activities for more than a decade. And also, even in Tokyo, when we discuss with some VC executives, some of them concerning about the shortage of newly founded startups, because now Tokyo, they have several VCs and they actively invested to the university-based startups. But there is a great competition among VCs. They need another new clients. But then how about the number of clients? Honestly, they not so much. So this is another great limitation. So my question is about that. Does the ecosystem require a critical mass of new startups? Because as you see, as long as we say that the ecosystem, this system must be sustainable and maintain their activities. So the important thing is the input. The number of spin-off must be a great input to this ecosystem. Otherwise, the VCs and professionals cannot maintain their business. However, even in except in the leading cities or leading innovation district, the number of newly founded startups is limited. Here is a case. So this is a number of university-based startups. This means university technology-based startups. So for example, in the United States, even in the leading cities, they have 50 or more startups annually. But even in London, they have only 20. And in Tokyo, we have only 10. So the number is limited. Of course, the startups are not limited to university technology-based startups. We have also student-based startups. Well, there's recently we have an interesting survey focusing on alumni-founded startups. Indeed, these leading cities, they have 100 or more startups. But how about other cities? This data is only limited to US cities, so that we don't have any London data or Australian data and the Tokyo data. Well, here is a case, Atlanta. Even in Atlanta, very famous in innovation area, but they have only 20 alumni startups, so very limited. And as long as I surveyed the Japanese data, I also found that in Tokyo, they have only around 10 student-based startups annually. So this is a great limitation. So, well, when I consider about university-based startups, particularly the technology licensed startups, I assume that there is a great constraint to create a startup. The constraint is here, particularly as one faculty hardly to be serial entrepreneur. There is several reasons. One is about the commercialization probability or commercialization feasibility of their inventions. Even the best case, 50% of invention can be commercialized, whereas the very few faculties have 2 or more patents. Another constraint is about the balance between the academic activities and the commercialization activities. But through the constraint it's a social constraint. Once a faculty contributed to a specific spin-off, he or she may socially locked in the company. So that's why they have hardly to give another to contribute to another spin-off startup. So here's the evidence. I and my colleague investigated a university licensing record. And we investigated the PI, principal investigator level data. So our observation is about 850 licensing data. This is by PIs. So these results means once the PI committed to a joint application with the startup and a license with the startup, they are less likely to license to startups, particularly to license to university spin-off. This means the commitment to specific startup greatly decreases the probability to license to a startup. This means the commitment to a specific startup decreases probability of a new startup foundation. Okay, another issue is the mental issues or communication issues. As I mentioned about in the Hongo Dari case, I mentioned the collaboration is very beneficial to receive a mentoring and frequent communication with the mentors. But the typically lagged innovation district or lagged entrepreneurial ecosystem, it's very difficult to have a specific VCs or any other mentors in this region. So usually they have some virtual network with VCs in leading regions. But yeah, this is the virtual network is. We do not have a specific evidence about this virtual communication is effective or not. Though maybe the COVID-19 changed the situation, so we do not read the specific conclusion. Though I raise a question about this. Okay, then finally, I want to link with the star scientist argument. Because the star scientists, they produce great numbers of patents and publications, and also as startups. So the two constraints I mentioned, resource constraint, commercialization, feasibility constraint, and other academic activities and patenting activities balance will be resolved because they have a great productivity. So this is a potential. So for example, in the case of bioscience field, the patenting stars, this is wrong. The stars in patenting may have 10 or more opportunities to found startups in their lifetime. And another factor is the stars will attract the talented students as well. And also students are potential entrepreneurs in entrepreneurial ecosystem. So students will contribute to startup foundation on behalf of their locked-in faculties. So I think this is another opportunity to maintain the ecosystem. And of course, these third scientists they have a lab and they have maybe some offices. So potential entrepreneurs are collocated in the very, very dense area or even in the same room. This may be a great benefit in the communication with far located VCs and professionals. So that's my last words. Thank you very much.
Thank you very much. We are running out of time a little bit, but let's ask 1 or 2 questions from the floor, and I will try to manage the time, including 2 more sessions. So please have a questions. And probably larger Japanese ecosystem discussion can be done after 2 more presentations altogether.
Yes, it's a good idea. Probably can continue with the presentations and come back to the questions.
But do we have a specific question for Yoshioka?
Currently we don't have any comments or questions.
Okay, then let's make
questions
together. Okay,
so you want ask one question?
Then just great.
So just continue. I think you retain the microphone.
Thank you for the presentation. It was really interesting. I just wondered, when you talked about the startup lab in one of your slides, what academic discipline was that in? It sounded like it wasn't situated in a business school, for instance. It was more to do with a technology application and start up around that technology application. I'm just interested in knowing a little bit more about that startup lab.
Thank you for your question. Indeed, the all labs are in the discipline in engineering. So, for example, robotics, material science, and information processing. So they they contribute to average 5 or more startup foundations.
But also medical as well, isn't it?
Yes, medical. Sorry, medical is as well, and the pharmaceutical research as well.